Okay, of the entire circle. All right, the area is 295.52. The area of the sector is also given. That's 55 square inches. We're supposed to find this stuff. Okay, so we're supposed to find the radius. Do you know the formula for the area of a circle?
Area of circle.
Yeah, the formula for the area of a circle.
Oh, A equals pi r squared.
Correct. Let's use that. So if we know that the formula is area equals pi r squared, okay, but we're given the area of the circle right here, 295.52. We could go ahead and put that in for area right now. So that's going to give us 295.52 equals pi r squared. Okay, we're supposed to solve for the radius. So, how can I get rid of this pi?
You divide it.
You divide it by both sides. So we'll just divide both sides by pi.
The other one cancels out.
Correct. Okay, so those are going to cancel each other out. Now, so now I've got r squared equals 295.52 over pi. Now, I like to leave things until the last minute. So I've got 295.52 over pi equals r squared. Now, how do I get r by itself? How do I unsquare it?
Square root.
You square root. Okay, so I'm going to take the square root of both sides, like this. Okay, so then just put that in your...
I got 9.6698.
Okay, 9.698. So we'll round this to 9.7.
And we keep pi.
No more pi because that was in there. That was under the radical. It went into making that expression. It's part of the decimal now. Okay? So that is the answer. We were supposed to find the radius, and we found it. Okay? Now, you weren't in the class at first when we first learned how to do this. Do you know the formula for the circumference of a circle?
C equals 2 pi r.
Correct. Circumference is equal to 2 pi r. But thanks to problem number 16, we now know what r is. So we can just go from there. Circumference is equal to 2 times pi times 9.7. So I'm getting 60.946, so 60.9. So that's how you do number 17. Okay, so there you go. That's the circumference. All right, let's see what's next. All right, now we're supposed to find the measure of arc PQ. Okay? All right, this is where a lot of people get confused. Well, the main thing you need to understand is we're basically being asked for degrees. All right? With that little m there, it means degrees. We need to find this angle. Okay? But here's the thing. You know how when we have a sector like this, we normally do part over whole equals part over whole? We're going to set that up right now. Okay, we're doing part over whole equals part over whole. Now normally on the right-hand side, this is where we do all of our degrees. You can't. Okay, so normally over here, this is where we do our degrees. Okay, but we don't know the partial degrees this time. We don't know the angle, so I just put a variable there. Some kids would put x. I always like to use theta when I'm talking about angles, unknown angles. What always goes in the bottom degrees?
360.
Always 360. Okay, now this is only going to work out if I know everything else. Okay, so on this side, I'm doing part over whole. Partial area over the whole area. Do I know the partial area, the area of the sector? I do. If I read these sentences, somewhere in there it's going to talk about the area of the sector. It's 55. Now read and read. Do we know the whole area? We do. Read.
295.
Sure. The area of circle R is 295.52. They're giving us the whole area. So they've given us the partial area of the sector, 55, and they've given us the whole area of the whole circle. So part over whole, 55 over 295.52. Okay, so we know everything except for theta, so we should be able to cross multiply and get this. Okay, so that's what we're going to do. 0.52 theta. Okay, cross multiplying, I get this. Of course, now what am I going to do?
Divide by 19,800 to both sides.
That's close. We're going to divide, but remember, we're trying to get theta by itself.
Oh, you divide by 295.
Exactly. So I need to divide both sides by 295.52.
I got decimal.
67, all right? Even round to the nearest hundredth, that's going to be 67. So we'll put, so theta is 67 degrees. Okay, so that is the answer to number 18. That is the angle, but of course the angle is equivalent to the measure of the arc. Okay, now we are supposed to find the length of arc PQ. All right, and now that we know that this is 67, let me just move this so it's easier. Okay, so now we know that this angle is 67 degrees. So we should be able to find this length the way we used to, by doing part over whole is equal to part over whole. But now on the right hand side, we can do 67 over 360. Okay, and we'll let x represent the partial length, the arc length that we're looking for. Now, we still need the whole length. Now, do you remember what the whole length is called? There's a word for it. Starts with a C.
Circumference equals pi. I mean 2 pi
2 pi r, okay? The circumference. So if I'm talking about length, the whole length is the circumference. So we're going to have to do 2 pi r. That means I need the radius. Luckily we found that on the previous problem. I just need to switch back. We found previously that the radius was 9.7, okay? So this radius is 9.7, so we'll just borrow that and substitute it. Alright, so that means the circumference is 2 pi times 9.7.
$19.4.
19.4. That's not big enough. Maybe it's 19.4 pi. Did you forget the pi?
Yes.
So is this 19.4 pi? Okay, so 19.4 pi. Okay. Does 67 over 360 reduce at all?
Yes. I mean, no.
Okay, so we're stuck with the big number. So we cross multiply. So this is going to make 360 x equals
1,299.8.
okay, 1,299.8 it is. Okay, so we don't have pi in there yet, so this will be 1,299.8 pi. Am I right? Okay, what's the last step?
Divide both sides by 360.
Divide both sides by 360.
Got 3.61.
Circumference.
I can reduce.
Well, since we have decimals anyway, we're just going to go ahead and get a decimal for the final answer. So let's see, 1,299.8 pi.
Got 3.61.
I didn't make it play. So,
3. We'll just call it 11.3. Okay, so that is the answer. All right, that's the length of arc PQ. Okay? What's next? Oh, perimeter of the shaded region. Okay, perimeter. Do you understand what that word means, perimeter? Tell me what you know about perimeter.
I mean, something to do with the center. I mean, shade it this side.
Okay, just as an example, just so I can make sure we're on the same page. Say if I had a square. Okay? And say this square had sides 5, 5, 5, and 5. Could you tell me what the perimeter would be? Yes. The perimeter would be 20, because the perimeter is the sum of all the sides, all the lengths around the edges. All right, so in that case, the perimeter would be 20. Okay? So, we're supposed to find the perimeter of this shaded region. So that means we have 3 lengths to add up. We have these 2 lengths to add up, and we have a third length, the curved length. Let's see, I'll make it blue. Okay, those are the 3 things I have to add up. Now, luckily on previous problems, we found all 3 of those things. Okay, let's start with this one because I already have the right color ready. This is the length of arc PQ. That was what we just found on problem number 19, the length of that arc. That was 11.3. Okay, so right here, 11.3. Okay, now, these pink ones, RP, RQ, that's the radius. All right, I'm pretty sure we found the radius,
Oh, the radius is 9.7?
9.7. Blank, blank. Yeah, that was problem number 16. All right, so the radius is 9.7. Okay, so the perimeter is going to be the sum of these 3. So just add them all up. $30.7. Okay. So that's the perimeter of the shaded region. Now, for number 21, we need to do the perimeter of the unshaded region. Okay? So let me modify this a little bit. All right, let me get rid of that blue part. Now, the unshaded region, let's see. This part in pink is part of the perimeter of the white part, the unshaded region. Now the rest of the perimeter is this area that goes all the way like this.
So that's like 360.
Well, that would be degrees, so we have to be really careful. We're not going to do 360 because it's not degrees. This is length, like inches, or yeah, inches. So, but you're on the right track though. We have the 9.7s. So the key is somehow we have to find that red length. Okay? Now, when you said 360 at first, you were talking about the whole. You were doing degrees, but let me take that the same concept. We will do the circumference. All right, if we do the circumference, that would be the entire length, okay? And then subtract arc PQ. That'll be our strategy. All right, we will get the red length if we do the entire circumference minus this arc PQ, okay? The arc length, not degrees, but the length. We've calculated the circumference in a previous problem.
11.3.
Circumference was 19.4 pi. We're going to need the 11.3 also, but 11.3, that was the length of the arc PQ. The circumference, that's when we did the 2 pi r.
That was number 19.
Yeah, on number 19, the 11.3, that was the arc length that we found. So we're going to use both of those. So the circumference was 19.4 pi. So we'll do 19.4 pi minus the arc, PQ. We found that was 11.3 in problem number 19. So we'll do minus 11.3. So if we subtract those two, that should give us this red area going around the backside of the Pac-Man. So we'll just put that in the calculator. 19.4 pi.
49.64.
Right, 49.64. So let's say 49.6. Okay, now that's just the red part. So the perimeter is going to be the red part plus the two pink parts. It's the entire border all the way around the Pac-Man.
So we're going to add 49.6 to 9.7.
Correct. So for the whole perimeter, the perimeter should equal 49.6. I should draw a line here. 49 plus 6 plus 9.7 plus 9.7. All right, tell me what that turns out to be. 69. That was exactly 69? 0.05? Okay. All right, but you could round to 69. Okay, and that's the perimeter of the unshaded region. All right, so that is how you do that part. All right, I'm going to end this video here, and we'll do the rest on a second video.